So in this slide, guys, we're going to be looking at a fraction of an amount. And we're also going to be looking at different topics, so working with surds and square roots, okay, and obviously fractional and negative powers, and how to do general subtraction, okay. So part A, we're asked to find or work out 2/3 of 12. So to work out a fraction of an amount, guys, a fraction of a quantity, we divide by the bottom and then times by the top. So we do 12 divided by 3 is 4, and 4 times 2 is 8. So we divide by the bottom and then times by the top. Next up, part B, similar process or same process, 5, 8, so 40. We do 40 divided by 8 is 5, and 5 times 5 is 25. Okay. Part C, 3/5 of 10. So we divide by the bottom and then times by the top. So 10 divided by 5 is 2. 2 times 3 is 6. Part D, 3/7 of 21. 21 divided by 7 is 3. And 3 times 3 is 9. Next up, part E, 4/9 of 18. So we do 18 divided by 9. And then we times it or multiply it by 4. So 18 divided by 9 is 2, and 2 lots of 4, 2 times 4 is 8. Okay, next up, part F, 2/3 of 9. So we do 9 divided by 3, and then we times it by 2. So we do 9 divided by 3, and then we multiply it or times it by 2. So 9 divided by 3 is 3, and 3 times 2 is 6. Part G, 5/6 of 36. So we divide by the bottom and then multiply or times by the top. So 36 divided by 6 is 6. 6 times 5 is 30. Part H, 3/4 of 24. So we do 24 divided by 4 is 6. And 6 times 3 is 18. So again, we divide by our denominator and then multiply by the numerator. Okay, so divide by the bottom and then times by the top. Part I, 3/5 of 20. Again, we do 20 divided by 5 is 4, and 4 times 3 is 12. Next up, part J, 2/5 of 66. So we divide by 11, and then we multiply or times by 2. So 66 divided by 11 makes 6, and 6 times 2 makes 12. Part K, 3/10 of 160. So we divide by the bottom and then times by the top. So 160 divided by 10 is 16, and 16 multiplied by 3 or times by 3 is equal to 48. Finally, part L, 7/8 of 16. Again, we divide by our denominator and then we multiply by our numerator. So 16 divided by 8 is 2, and 2 times 7 is 14. Okay, so to work out a fraction of an amount, we divide by the bottom and then we multiply by the top. So divide by our denominator and then multiply it by our numerator. Okay, that's the first section done. Okay, the second section, okay, has to work out the following. So part A, the square root of 16 is going to be 4, because 4 times 4 is 16, and 16 is a square number. Part B, the square root of 36 is 6. The square root of 4 is 2. Oh, that looks like a B there. Okay, the square root of 9 is just 3. The square root of 100 is equal to 10. The square root of 1 is just 1. The square root of 25 is 5. The square root of 49 is going to be 7. The square root of 81 is going to be 9. And the square root of 64 is going to be 8. Okay, now this has been done here, not now actually, but this is like introducing here the idea of surds. So these are all actually what I call here square numbers. Okay, these are non-surds, so not surds. Okay, a surd essentially is the square root of a non-square number. Okay, so for example here, root 2 is a surd, root 3 is a surd, root 5 is a surd. Okay, root 1 is not a surd here because root 1 is just 1, and root 4 is not a surd here because it simplifies to a whole number or like a terminating decimal. Okay, but yeah. But for the purpose here of GCSE, yeah, we're looking at square roots here of whole numbers. But you can obviously have square roots here of like decimals, so bear that in mind. Okay, next up. So for each of the following, if it's a third, circle it, otherwise put a cross next to it. So root 5, that is a third, because I can't think of a whole number, okay, or even a terminating decimal that multiplies. Give me 5, that's not possible. Okay, root 16 is not a third, yeah, because that gives you 4. Root 7 is a third, because 7 is not a square number. Okay, root 8 is a third, because 8 is not a square number. Root 9 is not a third. Okay, root 15 is a third. Root 25 is not a third. Root 1 is not a third. Root 6 is a third. And root 4 is not a third. Okay, so a third essentially, okay, is an unsimplified radical. What does that mean? It just means the square root of a non-square number, or the cube root of a non-cube number, or the fourth root of a non-fourth number. Okay, but for the purposes here of GCSE and even A level, we look at square roots here of whole numbers. Okay, but please note here that you can get, for example, this probably doesn't make much sense here. You can get like the square root of, let's say, like 0.09. Okay, if you plug that into your calculator, that will give you 0.3. So the square root of this decimal is not actually a third, because it gives me either a whole number or a terminating decimal. The key is it cannot be terminating, okay? So we can have repeated digits, okay, but it cannot be terminating. So it has to be either a whole number or a decimal. But as I said just now, we work with roots of whole numbers, okay? But you might technically see the square root of a fraction or a decimal, which will give you a fraction or a terminating decimal, okay, as I said there. Or for example, if I have the square root of 4/9, okay, that'll be the square root of 4 over the square root of 9. The square root of 4 is just 2, and the square root of 9 is just 3. So the square root of 4/9 here will give you a reoccurring decimal, but will give you either a fraction, or a decimal answer, if that makes sense. Okay, so some exceptions here to the rule, but as I said, we obviously work with whole numbers. But I'll put it on the just like extension in case that you choose to extend it to obviously like to rational numbers, rather than just whole numbers. Okay, but for the purposes of GCSE and even A level, we work with whole numbers, okay, and roots. Next up, that's to evaluate part A, 14 to the power of 0. So anything, as I said before, anything, and I mean anything, okay, to the power of 0, singular, is just 1, with one caveat. We can't have 0 to the power of 0. So that is what we call, indeterminate. So, okay, part B, 3 to the power of 0 is just 1, 5 to the power of 0 is just 1, and x to the power of 0 is just 1. Next up, evaluate part A, 49 to the power of a half. That will be the square root of 49, so the square root, okay, the positive root of 49, which is just 7. So power of a half in maths means a square root. Okay, part B, 64 to the power of a third. That will be the cube root, or the third root, or the cubic root of 64, which will be 4. Next up, 125 to the power of a third will be the cube root of 125, which is just 5. And then finally, part D, okay, a bit more tricky, this one, 16 to the power of a quarter is the fourth root of 16. So what number multiplies by itself 3 times, okay, or 4 times in a row to give you 16, okay, that'll be 2, okay, because 2 times 2 times 2 times 2 gives you 16, okay, or 2 to the power of 4 is 16, okay, for that. And then similarly here, 5 times 5 times 5 gives you 125, and 4 times 4 times 4, or 4 by 4 by 4, is 64, okay? And similarly here, or conversely, 7 lots of 7, or 7 times 7 is 49. Next up, we're asked to evaluate part A, 25 to the power of 3 halves. That will be the square root of 25, all cubed. The square root of 25 is going to be 5. We have 5 cubed of 5 to the power of 3, which is 125. Part B, 8 to the power of 5 thirds. That will be the cube root of 8, and I'm going to raise it to the power of 5. The cube root of 8 is just 2. We have 2 to the power of 5, which is 32. Part C, 49 to the power of 3 halves. That will be the square root of 49. Okay, the second root. And I'm going to cube my answer. The square root of 49 is going to be 7. We have 7 cubed, which is 7 times 7 times 7. Well, 7 times 7 is 49. And 49 by 7, okay, gives you 343. Okay. Sorry, yeah, I didn't actually quickly, yeah, I did it on my calculator. You can obviously work out here in your head if you want to. Okay, or on paper, sorry. Okay, but 7 by 7 is 49, and 49 by 7 gives you 343. Part D, 16 to the power 3 quarters, that will be the fourth root of 16 to the power of 3. The fourth root of 16 is going to be 2. 2 to the power 3, or 2 cubed, is equal to 8. Okay, so when you have a fractional power, okay, you do the root of the number that's on the bottom of the fraction, and then raise the power of whatever number is on the top. Okay, next up, evaluate part A, 5 to the power minus 2. That means 1 over 5 to the power of 2. Okay, so that negative power makes it 1 over, okay, whatever it otherwise would have been. So the numerical power obviously stays the same, but yeah, that negative makes it 1 over. We have 1 over 5 squared, which is 5 times 5, which is 25. Part B, we have 4 to the minus 3. That's 1 over 4 cubed, or 4 to the power of 3. And 4 to the power of 3 is 4 times 4 times 4, which is 64. Finally, part C, 2 to the power, sorry, yeah, part C, sorry, not, yeah, we have 2 to the power minus 5. That's 1 over 2 to the 5, which is 1 over 32. Finally, we have 6 to the minus 2. 6 to the minus 2 is 1 over 6 squared, which is 1 over 36. Okay, that is working with negative and fractional and powers of 0, okay, in this slide. Okay, final part for today, which obviously I've done there, was to work out 120 minus 89, so we can do our column subtraction. Again, it's there, yeah, if you take a screenshot, so we've got 120, we're going to subtract, we're going to minus, we're going to take away 89, okay, working from right to left. 0 take away 9, I can't do, so I need to borrow. That becomes a 1, that becomes a 10. 10 take away 9 is 1. 1 take away 8, I can't do, so I need to borrow. That becomes a 0, that becomes a 1. 11 take away 8 is 3. So you're going to have a final answer of 31. Okay, again, take a screenshot that you have if you need to get any point. But yeah, I've just put it up there here again, so you can see my workings. Okay, yeah, if you find that a bit too challenging or a bit too tricky, you can always do 120 subtract 90 instead, and then add 1 at the end. Okay, if that helps. So 0 minus 0 makes 0. 2 minus 9, I can't do something to borrow of that. Okay. Now I've got 12 take away 9 will be 3, and then I can add on 1 at the end, because taking away 89 is the same as taking away 90 and then adding 1. Okay, so 30 add 1 is 31. Or another way, if you want to is to do, so if I subtract 1 from both of these numbers, if I do 119 minus 88, that might be a bit easier to work. Okay, not too much easier. So 9 take away 8 is 1. 1 take away 8, I can't do so to borrow. That becomes a 0, that becomes a 1. 11 take away 8 is just 3. Okay, that is another way. Okay, but if you're trying to avoid like the whole problem of like borrowing, maybe do 120 even minus 100, okay, in your head, you're on paper, and then add 11. Okay, so that is another option. You get 0 to 0, and then you add 11. Okay, so you avoid having to borrow. Okay, that's probably the best method that avoids borrowing. Okay, so subtracting 89, same as subtracting 100 and then adding 11. Okay, but that is working with subtraction.